Let's put these ideas to practice. Let's see how to compute the demand function for a specific experience utility curve, which is given by A times the natural logarithm of X plus the amount of the composite good that you consume. The first thing to notice here is that the marginal benefit function with respect to X is just A divided by X. And if you plot that marginal benefit curve as a function of X, basically it looks like this. It never crosses the vertical axis, therefore there are never corner solutions, and it goes to 0 at X goes to infinity. That means that all of the solutions are going to be interior, and we know that X star of P is going to be given by the solution to B prime of X equals P, but this is just equivalent to A over X equals P, which implies, just by flipping here and there, that X star of P is equal to A divided by P. Very, very simple. To highlight the point that I was mentioning in the clarification at the end of the previous video, if you think of this function from this perspective as the marginal benefit function, this function is A divided by X. If you think of this function from this perspective as the demand function, is equal to A divided by P. It's the same locus of points, but it's a different function. I hope this helps clarify that point. I also want to introduce you to a concept that we are going to see time and time again in applications, which is we are interested on what happens to the solution of the problem, to the state of the economy, to the state of the market, with some parameter changes, maybe due to policy, maybe due to a natural shock. So one natural question, for example, is to ask what happens to the demand curve as the parameter A, which if you can see it here is a taste parameter that modulates how strong are your willingness to pay for X, increases. So it should be easy for you to see that if A goes up, the demand curve shifts to the right to something like this. And if A goes down, it shifts to the left to something like that.